All right, so function notation, let's take a peek. Now, this says evaluate each of the following given the function definitions and input values. So a couple things you want to be really comfortable with. And there's going to be three parts to a function. There's going to be the function name, it's usually a letter. There's going to be some sort of input value, and then there's going to be some sort of output value. So something goes in, the function does something to it, and then it comes out. So that function has a name and a rule. The name of the function here is g, and what g does, the rule of g, is it squares whatever you plug into it and adds 4. So you need to think about these in that way. You need to think about them as a rule, as a set of instructions. Think about that for a second. They're just a set of instructions. So whatever I plug into g, I square and add 4. And I know that because of this placeholder here, x. It says g of x. This is an example of the function g with an x in it. So here's g with an x in it. Let me use a different color. So this is g with an x in it right there. Now it says with g with an x in it, you square it and you add 4. So you know that rule is square and add 4. So no matter what we plug into g, we're going to square it and add 4. It could be a number, it could be a letter, it could be a sentence, it could be a pet. It doesn't matter. So I'm plugging in 0 here, so I'm going to square it and add 4. And that's going to give you 0 squared plus 4 is 4. Okay? Now, let's look at that function h of x. Why don't you pause the video for a second and give that a shot and start it when you're done. Go ahead and pause. Okay, this says whatever I plug into h, I raise 2 to that power. So I'm plugging in -2, I'm going to raise 2 to that power. So that's going to simplify to 1 over 2 squared because it's a negative exponent, and then we can square it and get 1/4. Okay? Now this little box right down here kind of does that and tells you what it is again. The rule is f, x is the input, y is the output, and so on. Okay? So let's keep on moving with this. No, let me see. Let me just lock this up here. Okay. Okay, now it says boiling water at 212 degrees Fahrenheit is left in a room that's 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and are given in the table below. In this scenario, the temperature T is a function of the number of hours. So H is the independent variable. The number of hours changes. T is the temperature. The number of hours dictates or controls the temperature. So this says from the table, evaluate T of 2 and T of 6. Now here's the thing. With functions, you can be asked to evaluate a function usually 3 ways. You can be asked with a table, a graph, or an equation. The last example we did with G and H, that was with an equation. This is with a table, and we're going to do graphs next. So when it says evaluate T of 2, that says take 2 and plug it in T. Now we don't know what the rule is, but we do have some results of the rule. In other words, I can't tell you what T of 9 is, because you'll see that there's no 9 in this, no 9 on that table. I can only tell you what T of 0 through 8 is. I can't tell you what 0 of a half is, 1 and a half, but I can tell you what 1 to 8 is, all the integers. So T of 2 is right here. T of 2 is 104. And then T of 6 is right here. T of 6 is 68. Now it asks you for what value of H, in other words, what input value is the temperature 76. So you got to find 76 on the T of H value or the Y value and figure out that it's at 4. So H is equal to 4. Then it says between what 2 consecutive hours will T of H equal to 100? In other words, when will the temperature equal 100? Well, if you look here under T of H, if you look here under T of H, there is no 100. But you can tell that it goes down from 212 to 65. So you got to find out where 100 would be. And it looks like 100 would be somewhere in here. So at 2 hours, we're 104. And at 3 hours, we're at 85. So somewhere in between 2 and 3 hours, the temperature went from 104 straight through 100 to 85. So between the 2 consecutive hours of 2 and 3. Okay? That's how you use a table with a function. Okay, let's go on to the next one. Okay, so here we are again. It says the function y is equal to f of x is defined by that graph shown below. Answer the following questions based on the graph. So you're still matching x values to y values or inputs to outputs, but now you're not doing it with a table or a graph, you're doing it with a function. You're doing it with an actual, you're not doing it with a table or an equation, you're doing it with an actual graph. So let me go ahead and put my face up here somewhere. Where can I put me? Right over there. Okay, it says evaluate f of -1. So I'm going to go ahead and I'm going to find -1 on the graph, which is right here. And it looks like f of -1 is 0. F of 1, here's 1, goes up to 4. So f of 1 is equal to 4. So you see, all I'm doing is I'm going to that x value and figuring out what the y value is, because this line represents the function f. Yeah, it's kind of terrible there. Let me just erase that. I can't. Yeah, we'll do it some other time. Okay. Okay, now, it says, evaluate f of 0. What special feature on a graph does f of 0 always correspond to? So let's find out what f of 0 is. F of 0 is right here, and that's 3. So f of 0 is equal to 3. Okay? Now, what special feature does f of 0 always correspond to? Remember, x is the input value and x is 0. When x is 0, you're on the y-axis, right? So that's always going to correspond to the y-intercept, always. So when somebody asks you for f of 0, they're asking you to figure out what the y-intercept is. Okay, now, you're all over there. Okay, now, it says, for what values of x solves the equation f of x is equal to 0? What special features on a graph does that set of values solve for? So remember, f of x is basically the y quantity. It says y is 0. So what it's asking you for is basically what are the zeros of the function. So the zeros are x is equal to -1 and 3. Okay? And lastly, this one says, between what two consecutive integers does the graph, does the largest intersolution f of x equal to 3 lie? Between what two consecutive integers does the largest solution to f of x is equal to 3 lie? So let's draw f of x is equal to 3. Now that's going to be the same as y is equal to 3. So that's going to be a horizontal line. I'll make it a different color. At y is equal to 3. Now, the largest integer solution for it, between what is right here, and that's going to be between this line and that line. Well, that's going to be 2, 4, 6, 7, and 8. So it's going to be in between x is equal to 7 and x is equal to 8. So it's going to be between x is less than 7, excuse me, less than 8 and bigger than 7. That's a good way to put it. Just like that. All right? Okay, let's see, is there any more here to do? That's it.